Sketch the following polynomials using intercepts, end behavior, and multiplicity. So we want to come up with a graph of these polynomial functions. The most important things is we need the x-intercepts, not necessarily the y-intercepts in this case, to match up, the end behavior to match up, and the multiplicity. So the x-intercepts are probably the easiest things. That's the location of zeros. So I'm going to have x equals -2 and x equals +1 as locations of zeros. So -2 and +1. My graph's going to go through those points. Now, if you'll notice, if you add up all the exponents here, which that's kind of a 1, and that's understood to be, the degree here is 4. So I have even degree for this polynomial, which means I'm either going to start in the positive direction and end in the positive direction for the end behavior, or I'm going to start in the negative and end in the negative. Now, normally we would start in the positive and end in the positive, but since there's this multiplier of -1 out front, that means this option is out, and I'm going to start in the negative and end in the negative. So start in the negative direction and end over here in the negative direction. Okay, and the last thing is multiplicity. So when you have multiplicity 1, if you'll notice, it's just the multiplicity is the degree of that particular point. So x minus 1 has an exponent of 1. It is multiplicity 1. All you do is just pass right through the axis there as a line would. This one has multiplicity 3. Since it is multiplicity 3, I'm going to pass through the axis, but it's going to hang around a little bit, so it's going to look like a cubic. Okay, so like that. And again, I'm not caring about what's happening with y-intercepts, so I'm just going to, since I know this is a continuous curve, it's going to look something like this. And then down here, let me get my arrow to match up with my curve. And then going down this way. And that's a pretty decent sketch of this particular polynomial.